Let's talk about alpha. And alpha is just an A here. Let's switch up colors here. So alpha is simply the probability that an interval will be wrong. Okay, and we find alpha by its association with the z-score. Okay, so we'll substitute the values into an appropriate equation to determine an alpha, right? So let's just think of the normal curve, right? And the normal curve looks like this, right? And the mean is set at 0, and that in this normal curve, we know that each half, let's call this the negative side and this the positive side, right? We know that each part of the normal curve represents 0.5 because we know that the normal curve is a probability, and the probability is from 0 to 1, right? So the whole probability of a normal curve, half of the normal curve is on the negative side, and the other half is on the positive side, right? So what we can do is with an alpha is we can determine the probability of how wrong we are. We can also call an alpha error, right? So if we're trying to determine the level of error with alpha, using the chart, we can determine the level of error, right? So let's just determine the level of error if we have an alpha of 95%. If we have an alpha of 95%, that means that we're willing to be wrong 5% of the time. So if we had an alpha of 99, that means that we're willing to be wrong 1% of the time, right? And let's look at this as a decimal, right? So 5% as a decimal is 0.05, right? And we already know that this represents half of a normal curve, right? So if we're willing to be wrong 5% of the time, that means that we need to divide it by 2 because this normal curve is divided by 2, right? So 0.05 divided by 2 gives us 0.025. And if we know that this is 0.025, now if we went to the back of our book to table number 5 in appendix, which reads standard normal distribution, the column that reads Z, so it looks like this. Going down, there are numbers, there are Z's, and it starts negative and so forth going down. And we have numbers on the top, right? And the numbers on the top were 0.0, 0.05, and whatnot, right? This represents our alpha. So if our table had an alpha of, if we could go in our table, we could find an area of 0.025, it would equate to a z-score of 1.96. And this will never change. You'll always get this z-score for an alpha of 0.05 or 95% as 1.96. We could do the same thing if you go down if you go to that table and you look at the bottom of the table, it has levels of significance. And the level of significance is alpha. And what you'll see is that there are alphas. There are alphas for certain levels of significance, right? So at 10, that means that you're willing to be wrong 10% of the time. and it equates to an alpha of 90%, which also equals a z of plus or minus 1.65. Okay. The same thing holds for if you're willing to be wrong 1% of the time, which equals 1%. That's the decimal, and it equates to a z of 2.575. Let's call these z's, right? And we already know if we're willing to be wrong 5% of the time, it equates to a z of 1.96. Okay, so these never change. These always remain the same. You can always go back to your back of the book to table number 5 in appendix, and it lists them.